hell? Wow, hey, all right. Hey, this is SkyTour LiveStream for 25th of July. And we are doing another NEOWISE stream tonight because it's there. You know, why not, right? I want to welcome you guys here. I see a lot of old faces and I see some new faces. Okay, I want to welcome Nick MWM to the stream. Hi there, how are you? Good to see you again. And I have a number of people that are joining us tonight for the first time in the chat. And I just want to say hello to all of them as well. It's so good to have you with us. And welcome to SkyTour LiveStream. SkyTour LiveStream is a wonderful live observatory. I know you don't see an observatory on the screen now, but it really is here. This is me here. This is, hi there. Okay. We're under red light here in the observatory office, and I'm going to take, for a second here, I'm going to take us to another spot. Okay. For those that haven't been here before, I go through this with all of you the first time, and I would like to just share with you what we're looking at. Okay. On the screen, okay, first of all, this is an alternative camera that we're using here. If we want to use our regular camera, the normal view that we have is this one here. Okay, this is our main telescope view. All right, and we don't have much in here right now. Although I gotta check to see. Let's see if we actually even have maybe some stars to see just for a moment. The comet is visible. I already just saw it a moment ago, and I shall show it to you. So this, okay, let me just show you what we're doing here. First of all, on our screen, the upper left here, this is the telescope control section. This is the north, south, east, and west. We can put in coordinates where we want to go. This is the access to the computer, the access to the focus control, and this is the access to the filter wheel. It's a wheel that rolls in front of the camera and allows us to use different types of filters. Right now, we're using no filters, so we're looking straight through. This way, without the filters, we see the natural color of the objects in the view. So I think that that is something that will be very cool. I'm not wearing my headphones tonight because right now we're actually not going to have anyone joining us at the moment. Daryl can't join us tonight. Amanda may be able to. She'll probably say something in the chat, and if she can join us, that's the time at which I'll bring her in. So I just want to keep on going here. Might as well, right? If you guys have any questions or comments, throw them in there. Also, at the end of the stream, if you want to see what was on the stream in any of our streams, I'm adding a table of contents for each stream into the descriptions, and I'm also doing that retroactively. I'm putting them into previous streams as well. So you know kind of where the Dumbbell Nebula is, where the lagoon is, and we start talking about it. You can just go right to that spot. So that's where I'm going. That's what I'm doing. I hope that's okay, and hope people enjoy that. Every now and then I may have to turn on my air system in here to kind of keep the air circulating. This is Arizona iced tea. Kind of apropos, considering that the second observatory we're building is in the Arizona desert. This is the one in Connecticut. Let me take us over to... I didn't finish telling you that this is the telescope control system. This is me. Hello. Over here is the observatory view right there. You can see the telescope in the view. And this is the camera control, so we can actually control a lot of aspects of the camera, if not all of them, right from here. Okay, so that said, I'm going to just take a shot. This will tell me what the focus is right now. This will be a 10-second shot at 320 ISO. 10 seconds right here, 320 ISO, that's the sensitivity. And now we'll see what happens. And we already see that because the telescope's sort of cranked over on its side, we will have to actually refocus it. I'm sorry, not refocus it, but reorient some of the images. As you can see, the main telescope is not quite in focus, and that's okay. We know how to fix that, okay? Because we remotely focus the telescope too. It's a remote system, so you see it here in the dome. We can control it manually if we want, but there's no need to. We don't have to. All right, and that's exactly that's why, because we can just go and control it from here. So we'll focus this as needed. We'll be back in just a minute to this. Hello, Diane Garner. Nice to see you. That's a person I haven't seen before. You're welcome to the SkyTour LiveStream. If you haven't subscribed, please do hit the subscribe key or subscribe button and click the bell. Hello, Carol Carol and I, look, and Marianne Robb is here. I did not expect to see you here, Marianne. And Randy was just saying what a wonderful person you are and how today went well. But it's nice to see you, Marianne. But you don't feel obligated to stick around, because you had kind of a busy day, and we can talk about that another day as well. But our hearts go out to you. So I think that's actually, I think that says enough. So let me go over to our other screen here, and this is a screen that has this is a observatory view of the comet, which is up here, and we're gonna bring this into our view. Let's just take a picture of it. We're at 125 ISO. Let's go way up. Let's crank it up a little. And this is controlling another camera. It's a wide field camera on here. And I'm going to take it and crank it up to, say, let's go to 800 for now. And we'll do it for the same amount of time. So 6 seconds at 800. Might be a little bright, but let's give it a shot and see what happens. Okay. There we go. Aha! Look at that. There's the comet. So let's get that comet centered in here, shall we? That's what we're going to do now. So to do that, what we do is we go to our control, and I'm going to do that first by actually going to our system here, and this is our main screen, main telescope view, and I have to bring this up a little more. All right, and I got an alert on my phone that the telescope has moved. I get alerts if it moves an inch. We love you too, Marianne, of course. And let's see. I'm gonna bring this up a little bit more. You just saw a star go whipping by. Actually, you know what I'll do? I'm going to tell it to go to the comet and see if we can center the comet in here. So off it goes. It's going to go to a bright star first. And how's it going to do that? Well, here we can see what it's going to do. Yes, the moon is out. All right. So here's where we are. We're actually in the Big Dipper, and we're going to this star right here. And then once it centers up that star, which is right there, that's a star right here, then it's going to take off and go to the comet location. All right. And you'll see the telescope is going to move to a different location. Holy cow, it's right near my, this is an exact view of my, what I see. Okay, so this is the house. Okay, And then this is the view I have. Okay, here's the observatory dome. Okay, so it's sitting there looking at the beautiful sky. We got a gorgeous horizon here. And the moon is going to be, it won't be a factor for long. But let me see if we can get a nice shot of the comet here. All right, so that's where the telescope is. The comet should be in the main view. And let's give it a shot and see if it is. We'll do 10 seconds at 320. That should be more than enough to see if the comet is here. I think it's right here. I could be wrong. That could be it. Yeah, I believe that's it. So when it comes in, I'll have to move it over. And we are, of course, out of focus a little bit, and I'll have to change that as well. All right, well, maybe that's not it. I need to focus anyway, so let me do that. So I will come in here to the main view once again. And now that star may be my focus star. So I'm going to grab this is my focus rectangle. And right there is where I'm going to center my focal efforts. And now what I'll do is get the star to move into there. And it's going to move in. I'm going to reduce the speed at which the telescope moves. Okay, and now let's do this. Yeah, okay. What's this song doing here? That's a wrong song here. Sorry about that. The Christmas music seemed to be blended in here. So, we'll find something else. Okay. So, we have that here, and now what I'm going to do is move a little bit eastward. There it goes. The star comes in. That's the star I'm going to use for focus. We're in a really highly magnified view, which I use for doing focusing. And this is the center of the focal field right there. Okay, a little bit the other way. Not that we need it. All right. And now I come over here, and over in this area here, these are the focal buttons. Okay, and so I have to hit one, and you'll watch the star. Now it goes out of focus. You can see it's just going out of focus, and it's actually telling the telescope to focus in the dome. And now I do the other one, and you'll see it drop down to a point. And as soon as it starts to dance around a lot, then we know that the star is nearly focused. And you always are careful, okay, to do it a few times. All right, so this looks like we're okay. Now I'm going to do 10 seconds at a slightly higher ISO, say 500. This is 10 seconds at 500. Marianne, yeah, I wasn't going to say anything, but yeah, Don Robb was Marianne's husband, and we had just had pizza together a couple weeks earlier when I was out in Arizona. Don was a good friend, good man, captain of the Mesa Fire Department, retired as captain, and he unfortunately passed away. And that was just, a couple weeks back. So why Marianne is here, she doesn't have to be, but you know what? That's who she is. She's dedicated to everybody else but herself. So we all have to kick her collective butt and make her, take some time for her, But I do appreciate her very much. She's been wonderful, tremendous help at the observatory, and you cannot find a better person. You really can't, and that's all there is to it. All right, let me see something here. I have to go south a little. No, east. I'm just gonna move us. Okay. All right. Oh, sorry. I had to focal view on. I apologize. Hey there, Tim F. How's it going? Good to see you guys. Karen Belmont. Let me get my thing back here. All right, where are we going here? I'm going to get my screen up here. There we go. Okay, and my target is 11:20, 20. So that's going to be coming up. And we got a, sometimes the right ascension and declination reported for the comet is not correct. Oh, and I can see why we're not getting that, because we're at the wrong, we want to be at 3939. I'm moving the telescope, as you can see the star is moving slowly. And interesting. Let's go and look at the other one. All right, and let's see what happens when we take this picture. This is, you can see the comet up here. Comet NEOWISE was named for the NEOWISE telescope. That's N-E-O-W-I-S-E. Look at that, it's gorgeous. And what I'm going to do is, so that's there. That's pretty close, actually. That's should be quite close. And again, the coordinates are not always dead on when you get them from different places. So I'm doing my best to get those coordinates, get them right. Let's see here. Okay, it's good. We got 40 people watching. Welcome, guys. That's the comet up there. Let me see if I can move this down. I know I can move us down. Let's get us going a little bit faster, shall we? And now we'll come down and go to this guy. And take this, and we're going to now bring us down. Actually, it's the wrong way. I'm going to go this way. Hang on one second. The main scope and the camera on top are just a little bit off, and I've got to align those. They're not aligned with the main scope yet. I guess it got bumped or something, and it did not. You're seeing stars whip by. Yeah. All right, so now, oh, I might have gone the wrong way. I did go the wrong way. Never mind. Up we go. Because that was kind of dumb. All right, now let's take a photo, not here, but over here. All right, and we're going to go to that specific screen. All right, now we'll take an image and see where it is on the screen. If it's not quite there, then we'll put it where it belongs. Yeah, I kind of blew it away, didn't I? No problem, because I know that it will. I know that it'll be right where I tell it to go. That's my dog. That's Dingo doing her thing. Okay, so this star gets moved in. You can see it right here. Okay, it gets moved in to be centered roughly to what it thinks it is. And then it goes away, and we go right to the coordinates that are specified by the comet site. And the coordinates are actually pretty accurate. So we'll see where it is in this view, if it's there at all. I know that it's actually in the other camera, it'll be up near the top. And we're going to actually confirm that again right now. So I'll take another picture, and it should be right here. There it is. So there's the comet. And now I know that our main scope is going to be looking very, very close to this. What I'm going to do is I'm going to go up to a higher setting. Let's go 2500 for 10 seconds in the main view. And see if we see any indications. The blue is because the moon is out, by the way. Just so you know. Okay, this is our current view. I don't see, but it's close. So what I'm going to do is I'm going to go into my 4K video mode and raise our ISO, and then I'm going to just do some localized locating and see. That was the wrong one. See if I can locate it. So first things first, let's give ourselves just a little bit of room to navigate. And let's see, we want to go north a little bit, and we're going to do a little hopping. Shouldn't take that much to do this. Okay, and we're going to go east a little bit. Okay, and then we'll go south. Again, the telescope's alignment is good. It's just that the comet, there it is. Okay, the comet is not exactly, well, look at that, huh? The comet wasn't exactly where the coordinates stated it was. In fact, where it is, okay, right now, and according to, okay, in the published record, it says it's 11 hours, 20 minutes, 20 seconds, and plus 39 degrees, 39 minutes, 43. It's actually off by enough to make quite a difference. Okay, but here's the comet in the main view, and I will show you that right now. There we go. This is Comet NEOWISE, and I'm going to move us over because I'd like to show you the extent of the comet's tail. And what I'll do over here is I'm going to get rid of the observatory cam for now, and I'm going to get rid of that, and the tail goes all the way out here and off the screen. But I'm going to shut off the 4K video right now and drop us down to a more reasonable view, like 6400 for 13 seconds. Okay, and I must do one thing before I do that. I've got to get into the computer a bit. So first things first, I know it looks like I'm doing monkey business, and it's sort of, I am. I'm just reaching into the computer on the telescope to make sure that I get right to setting some specific values for guiding. Okay, there's that one, and then this one, and we go in there again, and we do this. This is going to be 0, 1. It's like little codes to help the computer understand what I'm doing. Hey, look, a satellite. That just went through. Did you see that? The things you see in SkyTour LiveStream, let me tell you. Okay, now we are focusing on this green coma, or bright area around the comet. Because so much stuff is hurled off the comet by the sun's energy, it is it's a well, it's sort of an atmosphere in a sense around the comet, a temporary atmosphere. And that's what we're seeing here. Oh, look at that. Wow. Wow, guys, look at this. I'll tell you, NEOWISE is looking beautiful. This is the coma, the bright coma. Is that beautiful or what? This, let me give it to you full screen for crying out loud. Okay, you can actually see some really interesting things here. We look at the comet. This right here, this is the coma. The coma is got this green hue, and that green is due to cyanogen, which is a carbon atom and a nitrogen atom together bonded. And the cyanogen, if those of you that understand chemistry know, that's cyanide-ish. It's cyanide. It's not hydrogen cyanide, but hydrogen cyanide, of course, most toxic to us, along with cyanogen, is present on the comets, in the comet's atmosphere, this temporary atmosphere. And that's the chemical formula for hydrogen cyanide is HCN. So, HCN, hydrogen, carbon, and nitrogen. That's hydrogen cyanide, and this is cyanogen that we're seeing here. And if I just move out of the way for a sec, right up here, you can actually see the tail, this dust tail of the comet. Now, the dust tail of the comet is pointing in one particular direction, and the ion tail, yes, it has two tails, is pointing slightly different position. Now, let's go see where the other camera shows this, so we can actually get an alignment between this camera and the other one. Okay, so that is going to be over here, and let's go to here, and let's take we're going to go to 2000 ISO, and we're going to do 10 seconds. Boy, it's so nice. We have clouds coming in, and I wasn't sure we were going to be able to see anything tonight, but I actually watched it all day because I love you guys. I want to do this for you. So, okay, let's do 10 seconds at 2000 ISO, and the comet should be in the view because it's a wide-angle view. Let's see where it ends up. Okay, I'm so excited. No. Come on. Yeah. Okay, here it comes. Oh, look at that. Wow. That's beautiful. Okay, so the comet in the camera up on the wide-angle side is it's up high. So that tells me that's exactly where our alignment is for tonight for the two telescopes. All right, and that's fine. So what I'm going to do is I'm going to come back because I want to bring it down to a long exposure for you of that. And we're going to do that by doing the unthinkable. We're going to take the comet and we're going to move it out of this view because this is a very magnified view. We want to bring it down to a point where we can actually see it in the other telescope very nicely. So I have to go up, all right, and bring it down into the view. So we're going to bring it up, like this. Don't worry, we can get it back. I figured it out. Okay, so we're bringing it up. You're watching stars go by. All right, let's go check. It'll be just real quick. Is Mike going to be maybe around here? That's my guess. Let's find out, shall we? Because I want to take a long exposure to show you the extent of this tail in the wide-angle view. It's really cool. Look at that. Well, not only that, we had an airplane pass through at the same time. Check it out. Pretty interesting, I must say. So we're a little bit over there. So I'm going to move us now as well to bring that back in, and I'm going to figure out the best way. And when I do, you bear with me here for a moment. Okay. So the way I'm going to do that is I'm going to come over here and bring up our view here and move us this way. Okay. That should be good. And now this should be over here. Let's find out, shall we? Yes, Miss Robert Smith. The tail should be visible with binoculars. You'll see it maybe like you see it here on this screen, because I'm taking pictures that are going to approximate what you might see with your binoculars. Right? Like say it's going to be right about there. Let's see if I'm right. Oh, wrong. Okay, I get it now. We're still just out of the view. The camera apparently I have to do some more alignment, obviously. But I can do that. I can do that. All right, so let's do that. First, bring this over. It's beautiful, though, huh? It's a gorgeous comet. Ooh, yeah. All right, so that said, let's we're gonna go back to this guy, and we're gonna bring it up. Go up a little. Okay, up, and maybe more to the east. Let's just do a shot and see. I just want to center it up for you, and then I'll get it back in the other view too. It's gorgeous. So maybe it's gonna be up. I'm trying to get it about here, and then if I know where it's going, I can actually move it. Yes, it has a very long tail, huh? Hey there, Enrique. How you doing? Uh-oh. Guess I went the wrong way. I went the wrong way. Welcome from Chile, Enrique. Sorry, it's cloudy there. I know it gets that way. You know, here too sometimes. Let's try this. Okay, now we'll come back here, and we'll do this. I'm going to shorten the time just enough to grab enough of the comet so I can see where it is, and then we can move it faster. For those who really are joining us now, comic, oh man. Okay, I know how to fix that. One of the things I want to mention to you is that I'm somewhat of a perfectionist in SkyTour LiveStream. I want to make sure everything is just right, and that is a problem. You know, it's a sickness. I have to make sure that everything is just right. You know, and that's unfortunately my calling. This is SkyTour LiveStream East. This is on the east coast of the United States. And when August arrives, which is going to be in a few days, I'm going to be actually going to Arizona on the 15th, and we're going to be building our second observatory out in the desert. And I've already poured the pad. I was out there once already. 12 by 12 foot building, and we're going to be creating a beautiful experience for people that join us. We'll have SkyTour West and we'll have SkyTour East, two remote observatories. SkyTour East right now may end up leaving this location and going to a even darker location here in the east, which is kind of tough because there's not a whole lot of dark locations in the east that match the Sonoran Desert. But there are places that are really gorgeous. All right, let's do this in stages. I'm going to head to the west a little bit. I'm going to go to the west a little bit. Okay. And then I'm going to take a photo and see where it's gone. Look, there's the top of my house. So I went to the west, so that means the comet should be here? No. That's interesting. Okay. I might be looking at a... because when the telescope turns on its side, it flips the image, and it really it makes me nuts. So let's just do this again. We're gonna go this way. Okay. Oh, I guess that does make sense. That does make sense. Okay. And if I go this way, it should be coming down. Let's just make sure that happened. The comet is going to be, there we go, I'm getting it now, near the end of the, where you see the Big Dipper. Yeah, well, I'll show you. Duh. Okay. Okay, so this is the Big Dipper. Okay, and this is approximately where the comet is. Okay, this is the main scope, and I know that it's a little lower than the actual camera that took this wide-angle shot. So the comet's right about here. All right, so that's where that is. So that's roughly, and where the Big Dipper is right here. You can see here's the handle of the Big Dipper, and here is the bowl of the Big Dipper, and we know that the comet is right about there. Okay, so there we go. Now let's see. Let's go back here, and let me do this again. I don't know if I should. Well, I should probably do more of these. No, wrong way. I'll go this way again, and then go this way. Okay, and let's go see what that does for us. We should have the comet should be brought down a little bit more into the view. There we are. Good. And then we're going to take the comet and bring it even more into the view. So we're going to go east with it a little bit and then drop it down. Okay, go east again. I'm taking chances now. Okay, and drop it down. Okay, and now I'm hoping it's going to be right about here, maybe over here. That's what I want. And when it's there, then we can take some long photos of it. There we go. Okay, good. I understand. You know. Hey there, Lynch Hub. Kyle's here. Kyle Lynch. Tom Brown, how you doing? Yeah, I'm going to film that, Tom. I'll be filming the whole process. Diane Garner, hello. Well, I'm going to show you actually where it's going, and Diane asks where it will be going once it's gone from Earth. I'll show you, because it's going to be back again in about 6,800 years. You know, hey Daryl, and Daryl is here too. That's good. In about 6,800 years, it's going to be back, and it's going to be probably outstanding. You know, frankly, it'll be pretty darn nice. Okay, I'm going to take us, I think I'm going to go this way. Okay. The size of our field is a little less than half a degree, so I'm going in increments. So hopefully that's over here now. Might be a little down because the angle is odd between the telescope and the two telescopes that are out there. And that's something that is a problem. Yeah, see? So I can fix that by just, it's about where I want it to be though. Fix that just by doing some of this. And then some of this. I actually might be able to do this. And then some of this. Just changing some of the direction. Let's go see how that works. Meanwhile, I have a guide system out there, a guiding system, which is actually acquiring stars. And it's probably wondering what the heck I'm doing. It's probably saying, stop already, let me do something. You know? So this is just a quick 6-second shot. And as you can see, that's a little bit more well placed. So let's have some fun. Let's go to, this is 2000 ISO. Let's go up to 3200 ISO. How you doing, Daryl? Hey, Pogmo Thoin, how you doing? Man, it's getting dimmer as it's getting farther from the Earth. And so I will, Pogmo asked about, where is it in relation to the Big Dipper? And let me just get this photo underway and then I'll show you. We're going to do 15 seconds at 3200 right here. And we should see a tail that's a little bigger. Okay, so here we go. And now I will show you, this is the welcome screen, sure, but I actually want to show you something else. And I'm going to bring that up right here. Okay, so we're going to take the welcome off because you know that. Don't forget to look in the descriptions below for the locations and all the things we're looking at. That's good, Daryl. All right, now let me do this. Let me turn this off and turn this guy off. Okay, now looking here, okay, you can see this is where NEOWISE is. Okay, this is Earth out here. Okay, and NEOWISE has just gone around the sun, and it's heading back out into deep space. How deep? I know this ellipse looks like it's kind of just a narrow oval, right? But let me show you what it really looks like. Check that out. Check that out. Wait, there's Pluto, and it's still going. It's going out over 700 astronomical units so far that this view can't even show you the entire extent from the side, okay? That's our solar system. And it's going way, 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 way out into the Oort cloud, that cloud that is surrounding the solar system with objects that are barely gravitationally bound to the sun. And that's what's happening. So that's why it's going to be back in 6,800 years. Okay? And there it is, right there. That's NEOWISE. And so this is sort of a nice interactive simulator to show you where it is. And it's live. Everything is right where it belongs. Okay? So that is what we're looking at. Okay? And that is why it takes so long for it to come back. So let's see what we got here. This was my, was this 15 seconds or not? I can't tell. And it looks like it was. I'll do it again. This will be 15 seconds at 3200 ISO. Hi, Dan Delaire. How are you? Yes, it has dimmed quite a bit. Dan says he looked at it with binoculars and it has dimmed quite a bit. He's absolutely right. It has. It has. Daryl, Marianne, I think, left. She has a bunch of people at her house. And I believe she has left. Okay, let's see what we got here. Okay, so that was the 15 seconds. Okay, that's nice. You can see the tail going up here. Okay, here's what I'm going to do. I'm going to increase our ISO, and we're going to go to 6400, which is this camera's max, and then we're going to go to 25 seconds. All right, and it'll be a little bit brighter. But the tail has diminished somewhat. But again, that beautiful green, it's just beautiful. Yes, Daryl, I would enjoy it if you'd like to join us. That'd be great. Now I got to put on my headphones. I'm just kidding. Okay, just one moment, and we will be right with you. I'm going to be right with you. Hold on. Okay, so this is the 15-second shot. Now we're going to do the 25-second shot, and it should come in here. You'll see the information will tell us it's coming in. I'll tell you when it's coming. Meanwhile, I'm going to grab Daryl. Daryl, you ready to come in? Because if you are, I will bring you in now. Let's see. Oh yeah, look at that. You can see a big difference. We took a shot like this the other night, and this tail went right up, way up, but it's diminishing rapidly. I apologize ahead of time for the Skype sound, but I'll be right back to you.
Very good.
Hey, folks. Daryl Mason has joined us. Hi there, Daryl. How are
Hi,
you
Mark.
doing?
I'm okay. How are you? Hello, everybody.
It's nice to have you here, Daryl. It's a beautiful comet, in spite of the fact that we're actually seeing it kind of at a bit of a loss because it's not very it's not as bright as it used to be. But that green center is really stunning. This green cyanogen core is something else. Look at that.
I see that. Would you share a screen with me, Mark?
Oh, you know what? It might be helpful, huh? Yeah.
I'm looking at it on YouTube
Yeah, I'm
right
gonna
now.
change that. I just so folks know, I share the screens with people that are live with us so that they see it at the same time. Because there's like a 20 to 30-second delay, maybe less, for people on YouTube. So this way, Daryl can see things at the same time that I'm seeing them, so he can comment at the same time.
There it is.
You don't miss anything. Okay. All right. Hey, David Schmidt. David Schmidt is a teacher in Thailand, and he teaches kids there. And we've actually done brief little teaching with him. But I still want to do a class with him, and teach long distance learning. I think it'd be really cool. Hey, their build is set. Yeah, it looks like the comet's made of kryptonite. That's funny. Well said. Yeah. But it's actually the center is the atmosphere around the comet is cyanogen, which is carbon and nitrogen, and it's also there's also hydrogen cyanide, which is HCN, and there's probably no less than 25 or more other carbon-based compounds. Okay, there's formaldehyde, there's carbon monoxide, there's carbon dioxide. There's carbon. There's actually what's called C2. It's a carbon molecule, two carbons bonded together. And comets are well known to support a tremendous wealth of these carbon-based compounds. They're really comets are the ultimate carbon bigots, if you want to think of it that way. They're highly prejudicial to carbon. They really are. This is just incredible.
May I ask a question?
Yeah, please.
Are all the carbon compounds green?
No, actually, they're not. I mean, carbon dioxide certainly isn't.
Well, under stimulation of sunlight, that is.
The different no. The difference is that cyanogen glows a specific green. There are other, and they're called tautomers. They're actually other isomer. Well, let me explain. When you have a carbon, these carbon emissions like this, for instance, hydrogen cyanide. Okay, now the way that the molecule is laid out can change, and it can go between one or two different forms, maybe more forms, and this is it'll create a green glow for some of those layouts, as you might say. But then there's other layouts of the molecules that can happen as well, and it's somewhat temperature dependent, it's radiation dependent, solar radiation dependent, and those are tautomers. Those are a similar compound that have been kind of rearranged and screwed around a little bit, and you might get the same types of emissions, but it could make the difference between whether you see it like this or different. So the green color is characteristic typically of the cyanogen family of compounds on the comet. All right, and there's other spectra within a comet that show other things, including water. You can see H2O in a comet, as you might expect. Now, comets are actually relatively small, so if they were to collide with the Earth, they would do damage. It could cause an extinction level event if they're big enough. But the fact is, these comets are not. These comets are only partially responsible for the water on our planet. That now when we look at a comet like this one, all right, we see the green cyanogen, but we also see this long tail. We see an ion tail that'll stretch back here. If we took a deeper photo in a darker sky, again the moon is up, so the sky's a little bright looking. All right, but the fact is that when we look at the comet and we look at how the emissions come to us, then we can deduce a lot of things about these comets. And one of the comets that actually really helped us was Churyumov-Gerasimenko. Now, no, I'm not swearing, and no, that's not a new language. That's actually the name of a comet, otherwise known as Comet 67P. Now, Daryl certainly knew that, and we've been talking about 67P for a long time. And 67P is the comet that the Rosetta mission focused on. And you may remember that Rosetta, a couple of years ago, kind of made its way to the comet and ended up orbiting the comet from a few kilometers away. And it dropped a lander down to the surface, which the idea of the lander was it was supposed to fire these explosive bolts into the surface of the comet and hold itself fast and just anchor itself. Something went wrong, and when it fired the explosive bolts, they either worked partially or didn't work at all, and the thing just bounced off the surface, literally several kilometers up, and then, of course, the gravity of the comet, which is very small, which is why it went so high, it came down again, and it bounced like 1, 2, 3 times, and landed in a crevasse where it wedged solid. Now, eventually, of course, it got wedged in there, but eventually the comet's going to melt away. And when the comet melts away, it may very well disintegrate. Actually, to show you, hang on, I'll be right back. I'm right behind me. I got to show you that comet. I actually have that comet here. Hold on.
I wish I had a comet.
Okay, here it is.
It was the Philae lander, wasn't it?
Yeah, that's right. Well, this is the comet. This is Churyumov-Gerasimenko. This is I grew this digital model actually just the other day, and what's interesting about it is this is its shape. This is exactly what it looks like, and I might be able to make it easier for you to see. Just one moment. Let me do one thing. One ping only. Let me do this. Maybe this is going to do it. That should do it. Okay, so now this is the comet. All right, that's actually what it really looks like. The area where the data was lacking is why it's so smooth in some places. But you can see this weird shape and all these really, really intricate structures, okay? That's what we're looking at with comets, right? And I'm kind of in the way, aren't I? I should let you see the comet for crying out loud. This is not this comet, okay? This comet is unknown to us. We don't know what the nucleus actually looks like. But this is Churyumov-Gerasimenko, where Rosetta went. It orbited the comet and sent back information that allowed this really, really accurate digital model to be made. And I say accurate, but guess what? As of now, it doesn't look like this at all because there's been a lot of melting, a lot of changes made to it as it went through space. But here's what I want you to notice. Notice that it has a lobe here, and then it has a lobe over here. And there's a really, really narrow waist, almost like a wasp waist in there, isn't it? Well, maybe this comet started life as two objects that were in a close orbit, and then when they contacted each other, they cemented because that contact event will generate a little melting, and then they'll just cement each other with the melted ices that then refreeze. And this becomes what's called a contact binary. This might be what this was originally. Ultima Thule, where the New Horizons spacecraft went to, it found a very similar looking object, didn't it, when it actually encountered Ultima Thule. So this is what a real comet nucleus. This thing is about 2 miles across, all right, in real life. And most comet nuclei are between 1 and 10 or 15 miles across. This comet here, as Daryl told you the other night, is about 3 miles or 5 kilometers across. So you can see, what this looks like. Now this, all right, Keith from P&K Space Imaging is here. You can't have this, Keith. Every time he comes over, he takes something of mine, and he's probably going to want to take this. You can't take this. This is my comet, Churyumov-Gerasimenko, not yours. I'll make you one. Actually, we can we make those for people if they want them. They can have them. Okay. Now, so that's how that works. Now I just have to just bring back my background here. Okay, there we go. So now when we look at this comet, you can see, you can have in mind that this comet right here is probably gonna outgas and do the same kind of things, on its way out as it did on the way in, and as it went around the sun. Now, as it went around the sun, a good part of it was evaporated, and what's left is definitely different from what it went in with. So that's what we're noticing with this guy. Okay, now let me go back to, because the tail is so short, I think it would be a good thing if we head back to, and if you got any ideas, Daryl, let me know. I was thinking of putting the comet back in the main view and getting some photographs of it, because the tail is so small, it might actually make for a better view. What do you think?
Sure, you're the captain of the ship.
Well, but I take suggestions from the crew. We're all in this.
Yeah, let's get a close up of the comet head.
Okay.
I read something interesting the other day.
What's that?
You had commented you captured the striae, the striations
Yes.
in the gas tail.
Yeah.
I read that there was some speculation. I don't remember if I sent you the image or not. It was a very high quality image of the striations of the comet.
Oh, I think, yeah, I did, I think.
There was some thought that might have been an APOD photo. There was some thought that the comet's nucleus was, or the actual comet body was rotating rapidly and jetting on one side, and thus every time it rotated, it painted another stripe in the striations, if that makes sense.
Yeah, it does actually make sense, because I that's something that we can expect to see with a rapid rotator. And you got to remember that these comets outgas like crazy. They send out jets. I am on my Facebook page and in SkyTour LiveStream, and I'm sorry, all over Facebook. I had an explanation of what the comet nuclei actually looked like, and what they actually do. And I think that it's really incredible to actually look at how some of these jets cause things like the tail here, right? And that's something that's a really good indicator now of how the comet's actually working. I'm going to try something here. I'm going to go here. That's there. So I think I'm going to try this.
I remember, I think it was Hale Bopp,
Yep.
97.
Yep.
High power view of the head of the comet. You could actually see a jet emanating, a kind of a corkscrewing around the comet body.
Wow, that's pretty cool. I am going to do just a little 5-second shot here, or 6-second shot, just to. There we go. All right, so that should be pretty close. Let me see if I can. I'm trying to bring the comet in here. The coordinates as published are not accurate, incidentally. So I've had to hunt a little bit for the comet tonight. I probably caught them in between being updated, you know what I mean? Okay. You can see the edge of my roof over there. Okay. Okay, don't mind me, I'm just working on a couple of things here. No, wrong way. But that green is beautiful, though.
It is.
Yeah. All right, let me go here. And let's see. Unfortunately, the camera is at an odd angle to the main camera, so I end up having a problem with the alignment. I can't actually get it to align properly sometimes, and that's an issue.
That's live astronomy.
Yeah, that's right. We'll get it. I had it before in here, and I'll just get it again. Yes, sir. No problem. Says me. All right. We'll do this now.
Huh? We mentioned the other night that I think Amanda and I talked about it while Mark was out moving the dome. The cyan name in cyanogen and cyanide and all those, that's the same thing as the ink color cyan in four-color printing, or like the ink in your computer's printer.
That's right.
It means a particular shade of blue, maybe kind of a greenish blue. Cyan, magenta, yellow, and black being the four colors.
Yep. That's a very prescient comment, because it's exactly the same color that we see here, that cyan color. Cyanogen is called cyanogen for that very reason. Look, a satellite. I actually saw that pop, just pop through the image a few seconds ago. I don't know if you saw that. It went through as I was moving this. And that's the remnant of it, the last piece of it. Okay, this should be fairly close, so I need to take us. Let me look more time here. Okay, so that's what has to happen. The telescope has to go this way. Let me do let's just do a 13 at 6400 here. See if I can see a hint of the tail. I really wish that the alignment was better, but hey, that's what happens,
The alignment between the piggyback mount and the main mount?
Yes.
Yeah.
Yeah, it's off a little. So that doesn't do well for us. I had it in before, but I have to grab it and find it again. Not to worry. I'm gonna find it. Without a doubt. Go ahead.
I thought I saw it in the lower right there a few seconds ago.
Oh, did you?
Maybe.
In this view? Or
I thought, yeah.
How about?
I could have been wrong. It came and went really quickly.
Okay. Now let's go back to this. All right, that's down there. I should be able to see the tail. Let me. Because I put a indicator that tells me where the comet is. All right, so that's that. And now we will move it. Come on, come back. You got to get you back here. I'll do it this way. Okay, and then this way. Okay. Okay, do that. And let's go over here and do this. So taking two images at the same time.
All right.
Okay. And let's see this one. This looks, it might be nearby. Okay. It just bothers me that it was so, it was off by, I had the coordinates and I should have written them down. I had them, I said, okay, this is off by quite a bit here, and I was trying to figure out how far it was off. This was where it actually read where the comet was centered. I actually came to this, and these are the coordinates of the comet as given, but this is the other coordinates here were actually what they were, and I gotta see if I can remember them. It's in the stream too, so if I can go back in the stream, I can actually see exactly where we were to figure this out. Let me first of all just put the right view up here. We were at 11. I think it was 11:22. 11:22, I think it was. And 39. I'm trying to figure out where that was. Of course, I have to consider that the main telescope could have something blocking it right now, but I don't think so. Okay, so this, let me go to 11. I don't know. Don't know if this is right. Yeah, I'm not sure. Yeah. Wait, what was that? There it is. I found it. Okay. So I remembered. Good. I remembered. I was happy. You still there, Joe? Yeah, you are.
Yeah, I'm here.
Okay. Yeah, I
There it
found it.
is.
Yeah, I remember that this was like, it wasn't where it said it was. See, the published coordinates were 11, 20, 20, and 39, 39, or 39, 39, 43. And this is actually where it is. So I had to hunt for it. So I found it. That's good. And now we can play here for a while. And if we go here and look at where it is now in the wide field view, and we'll just take a quick 6-second shot.
I think maybe it was hiding behind your head the whole time.
Oh, I was not hiding behind my head. I would have felt it there. Yeah, okay. Yeah, that's where it is. That makes sense. Karen, thank you. I know you're running on fumes. It was good to see you here, Karen Belmont. You have a good evening, okay? And let's see now. So here we go. All right, now let's go back to our other view here. And this is now this will be our go-to view for the evening, because I think this is going to be better. So the moon will be setting soon. Let me go actually check that out. Okay, where is the moon? Should be gone by now. Yeah, it's either behind the house or it is set. I think it is set. So there's the that's where the comet is. And for those of you that want to see, here's the Big Dipper. Okay, there's the handle. There's the bowl. You look down below the bowl of the Big Dipper. Okay, and if you go straight down from the bowl, you're going to be a little bit to the right of it. But notice how much you're going down. You're going down. If you imagine this rotating to the left, if you rotate this to the left, this last star, Alcade, might come right in place here if you rotate it at the center of the bowl. So about that distance, about the length of the Big Dipper, but down below it, you can see the comet with binoculars. Okay? And that's really where it's located right now. So let's go and take some pictures of it while we're here. Good. So this is, now we're going to do, let's just try a 25-second shot, and we'll do it at 8,000 to see how it looks. Now, by now, I should have a guide star, and that's not a big deal. I just want to also make sure that we turn on the telescope view, and yeah, that's good. And now if I bring back up our telescope view, for those of you that can you see this little, right where my cursor is, inside the little inset here on the cam for the telescope view. Wow.
Nice.
That little light right there that you're seeing shows that I have a locked and operational tracker. So there we go. So I'll bring this up a little bit. Wow, this is beautiful. Holy cow, this is nice. Wow, really, really pretty. So I'm going to now take that and move it this way. Look at this, guys. Wow. That's really pretty. Really pretty.
It is.
So you guys, this is one you can actually see this tail going way out there. And now what I'll do is, now we can play. Now that we know we've got something good here, I want to take us over to to look at the comet in a different way. First of all, let's move it a little bit more to the east. I will get rid of the telescope view, and now I will drop this from 8,000 down to 5,000, and let's go 30 seconds and see what we look at. See how it looks. Okay, so let's bring it a little more east. Okay, and just a tad south. So it's right down at that edge. Okay, and now we have the tail going this way. Actually, you know what I'm going to do? I'm going to bring it up a little. Bring it up a little. And change the speed of our motion. So now we'll be a little bit better. Yeah, there we go. All right. So we should have a tail. When we looked at it before, we saw the tail out here, and we want to see the tail is going to definitely be out here. So here we go. 30 seconds at 5,000. It'll get more details. More details in the tail. Mm-hmm. Wow.
Tails are better with details.
I know. Yeah. I just want to welcome you guys to the stream. Thank you so much for coming out. We love having you. There's 55 of you watching right now. Last time we did a NEOWISE stream, we got over 2,000 views overnight. And we've gained over 700 new subscribers, and that's fantastic because that basically empowers us to keep adding to our arsenal of science that we do here. Look at that. Wow. And the guiding is good too, so I think we're going to try a lower no, actually, see the star right here, that little star right by the coma? We take a picture in a little while, and that star will look like it's moved, but it's not. The comet is moving, and we'll actually see that. So this is where it was a little while ago. Okay, see the star there? Now look. Okay, it's a little different. You can't really tell though. I have to make it pretty visible. For instance, to make it visible, what I've done in the past here is I have done the following. Okay, here is the, and I did this to show you, here is the, this is the comet. You can see it moving against the stars. If you look at the stars right near the comet, there's these two horizontal stars. And in the course of one night, look what we saw. Here's the comet moving. Okay? Isn't that incredible? Incidentally, you notice now the tail of the comet, right, has actually done something else. The tail of the comet has swung from being vertical in the sky to almost horizontal in the sky as it's heading on out. Now, the ion tail, which is this faint little line you can see up here, this faint, this bluish line, okay, the ion tail always points directly away from the sun. But the dust tail is lagging behind. It doesn't point directly away. It's still subject to the solar wind pushing particles past the nuclear head of the comet, okay? And as the stuff melts off the surface of the comet, the solar radiation, the ultraviolet radiation, will cause this to, ionize some of these particles. And when I say ionize, it means that it makes the electrons pop off these atoms. And now they're charged ions, and they stream back away from the sun, being pushed by the solar wind pressure. And they are a bright blue when they show up very brightly. The dust tail, on the other hand, is the liberated icy particles that come from the particles that are going up into the air over the coma here. And that dust tail kind of lags behind, and it has a weird, curve to it. So because it's mass, they're particles with mass and not just light and ions, okay? Because they're more molecular and larger atomic compounds, they will lag behind. And so the tail doesn't quite point away from the sun, but it still is being pushed by pressure from the sun. So it kind of lags behind in the orbit, lags behind, and kind of falls behind a little bit. So that's what happens there. And that is actually kind of cool. So now if we head back to our main view here, all right, this main view right here, okay, then you can see that we're gonna I don't think we actually didn't do the 30-second shot, did I? Is that the 30-second shot? I can tell you right now. Hold on. This is 5,000, and this was 25 seconds, I believe. Yeah. Oh no, this is 30 seconds. Okay, good. So this data that I'm referencing here is data that's on every single digital image that you'll ever see, and it's called EXIF data, exchangeable interface data, and it's actually an exchangeable interface file. And this data tells you up to 300 different characteristics of the photo, including the size, how long, the exposure, how it was filmed. Look at this. This is beautiful. And let me just give it to you on the whole screen, huh? Okay. Hey, Tara. Tara's here. How are you? I want to say hi to a lot of the people that are here. You know, we've got a lot of new faces, which I'm really pleased to see. You know, so I really like the fact that a lot of you have joined us and come here. This is wonderful. All right. And so just real quick, I see we have Cypher 2, we have David Schmidt, we have Bill Doucette, Daisy and Zoe Amethyst. That's wonderful to see you guys. I hope Lane has had a chance to see the Comet, Daisy and Zoe, you in here. And of course, you're here, Daryl, and that's wonderful. And is here. Anahata77, hi there, Bonnie, how are you? Dan Delaire, and Kathy Pernasek, how are you? Kathy, Amanda wanted to talk to you about something. Daryl, I don't know if you know what it was.
No.
Okay. And so it's great to have you guys with us. Trish D is here, which is wonderful. And Miss Robert Smith, nice to have you with us. This is really cool. I think that this is pretty awesome that you're here with us. And Tara, of course, is here. I think I mentioned you already. Tom, I said hello to. And Genghis is here. And Keith was here for a little while. P&K Space Imaging. If you guys have not subscribed to P&K Space Imaging, do it. They view the moon, and they do a spectacular job. They do it better than anyone. Hello, Diane Garner. Welcome. And I know that Dark Fury Gaming has not been here before. Nice to see you. If you have, I haven't seen you. My apologies. And we have a lot of new names out there. I said hello to Go Captain America. Hello there. And Dagger Spells is here. Hello. Nice to see you. Karen Belmont has been here and she's left. Neutrino is here. Gary H., nice to see you. And I'm glad you can see with a naked eye. That's something that is really, really, really hard. Brandy's here. Hello. If you have a dark sky, it's wonderful. And Governor Zzz, nice to see you. Zzz Ray. Okay, and I think that there's a few more. And I just, I try to make it a point to say hello to you guys that spent the time coming here. So I want you to know that I notice. Okay, Rachel Spitz, hi there. So there we go. So, I'm really pleased that you have come out to SkyTour LiveStream. I mean, why not? Look at this. Look at this view. Look what we got. We got a comet. The tail's going this way. We're going to do a shot now that's a little different. We're going to actually go to our... Oh, there goes a satellite. See it zip through right there? It went right across the tail of the comet. Had I been taking a picture, we'd see a streak across that. And I know I missed out, but... Oh, another one. Wait a minute. Let's just take a picture. See what happens. If we get more, we'll get more. You saw that. The second one went right behind it. So on the off chance that there was a trio, I'm going to see. This is a 30-second shot. That's pretty cool.
Getting to be unavoidable nowadays.
I know. That's true. Daryl says it's getting unavoidable. Can you get a little louder, Daryl, or no? I have to adjust.
Yes, I can.
Okay. Just need you to come up a little bit.
Try that.
Are you there?
Yeah.
Oh, okay. All right, sorry. Okay, we missed the satellites, but that's okay. You know, who wants satellites? But it's really, really pretty. I'm going to take us to another shot that I was trying to do before. I'm going to do it now. Okay, and that is that we're going to go to 1 minute, okay, and in an effort to catch some of the details, I'm going to drop down to 2500 ISO. Okay, kind of low, but I'm going to do it anyway. All right. So now, while we're waiting for that, it's going to be a 1 minute shot, so it's going to take a minute for this shot to come in. Let me get us that nice, crossfade to this beautiful illusion, this beautiful shot here. This is just stunning.
It is.
And like I said, we've talked about this. This is the cyanogen, center, right? And this coma can be up to 8 Earth diameters or more in size. That's huge, okay? And the tail that you see racing back and continuing can be, millions of miles in length. And tails and so forth of the comets are really spectacular. But the coma is often, the only thing people see. They only see that in binoculars. And I understand that this is the most prominent part of the comet, okay? But it really is what creates all the rest. Now we might have a live SkyTour radio show tomorrow. I'm working on it now, and we're actually going to be talking about comets again. But tomorrow, we're going to be doing an incredible amount of detail on what's going on inside the comet that makes all this happen. Just so you know, Daryl, that's where I'm taking this, because Daryl, as you know, is one of the co-hosts, as is Amanda. Amanda Curran is my original co-host with SkyTour Radio, and we just couldn't let Daryl keep sitting in the background. The guy is just too knowledgeable. Don't say it, Daryl. It's true. I don't want to hear any complaining. Okay? There you go. And he's very knowledgeable and really, really good at what he does, and that is amateur astronomy, telescope making. He's done an awful lot, and I think that that's why we wanted him on the show.
Oh.
Well, it's okay. And Bob Harless, I forgot to say hi to you, and Lost for Words. Hi there. Go ahead.
May I say, I think the gas tail is showing up better in the narrow field view tonight than it did the other night. If you use averted vision, like if you look above the comet, not directly at it, but if you look up toward the top right corner, but still hold that in view, I think you can see the gas tail a little better in the close-up view.
No, that looks like it right there, doesn't it?
Uh-huh.
Yeah, you might be right. And the gas tail is what we call the ion tail. That is the ion tail that we're talking about. Okay, we're still exposing. We're almost done with the minute. I'm not sure how the guiding's going to do, but I'm going to find out in a second. Yeah, he might be right about the gas tail too. And we talked about averted vision too, and you can see that this is a dusty color. All right, so this is just a little bit. I gotta just work on this a little bit. It's a little bright, and it doesn't make it more evident with this. But you know what I'm gonna do? I am going to make a change. First of all, look at the star. Remember I told you? And we've only done a photo a couple minutes later, and look at the difference now. Look at the star. It's there now. Okay, as it was there. See? Clearly, we're watching it move through the sky.
Sure are.
Yeah, pretty cool. I'm going to redo this guy, and I'm going to go with one of the filters, I think. I think we're gonna check out one of our filters here. I have a filter wheel on the telescope which allows us to rotate through to different filters. That section is down here. Now, if I hit this button, you'll see the 5 will change to a 1. Okay, as it goes to the first filter. That first filter is a narrowband filter. It's a real narrowband filter. So not a lot gets through it for moonlight and other kinds of light that are pollutants, but only the data that we want to see gets through. And then this is a slightly wider narrowband filter, number 2. Okay, and you'll see the comet shows up in there, and that's the one we're going to use. So we're going to do a 30-second shot here, and we're going to raise this up pretty high just to check it out, see if we can see that difference in the tail. All right, and it's going to be very noisy. That is to say, it's going to have a lot of grain in it, like you see film grain. But that's what happens when you're trying to take photos like this. Now, we don't see too much detail in here right now, and I'm not sure if the spectral response of the tail and the gas tail are going to accommodate us with this filter. But we have to try. We're going to try it. Now, I know that the ion tail is giving off blue light, and we are using a filter that will look for blue light. And as you can see in this image, holy cow, in this image we can see this blue. You see that, Daryl? That I think is the gas tail right there, that ion tail.
Yeah.
You can see the dust tail is a slightly different color, but this gas tail, that blue, is being distinguished between and from this other object. Okay, this dust tail. And we need to go a little bit longer in order to see that, I think. And also, I like to give you the benefit of seeing as much as you can. All right, that looks beautiful. Isn't that something? These are really pretty. Yep.
It is.
Dagger, thank you for sharing our video. I noticed that you did already. I got a notation. Thank you. Yeah, so let's actually go and do some more cometary exploration with this. Okay, now first things first, let's go see just where it is. Okay. All right, this is where it is relative to the trees. It's actually not that high in the sky right now. Comparatively, it is 19 degrees on the 19-degree line, I think, actually. So we do have to do our best to make sure that we capture it as much as we can before it heads behind the trees. And then we'll see what happens. All right, so that's our planetarium. It's tied to our telescope. Thanks, Farva. Sean Farva's here. Hey, man. How you doing? It's good to see you. And thank you so much for that donation. That's amazing. Thank you very much. We do run on donations, as well. It just helps keep the telescope going. That's all. I don't make any money on this. I don't expect to. So I'm humbled. Thank you for those that choose to hand us some donations at times. All right, let's go to... actually, I'm going to drop down. I'm going to actually go right down smaller. Let's go down to not 1.6 seconds, but let's go... I want to try and get the smallest possible view of the nucleus. Okay, 4 seconds at 5,000. Let's see what that'll do.
Out of the blue of the western sky, it's Sky King.
Yep.
Are you old enough to remember Sky King, the kid show? Mark?
I don't remember it.
Really?
Yeah.
Oh, they used to play it. Geez, I forget. Was that Captain Kangaroo or something else? It was a Saturday morning. It was not a cartoon. It was film, but
no, not on Captain Kangaroo. I used to watch Captain Kangaroo. That was
Yeah.
Bob Keeshan, who
Yeah.
played Captain Kangaroo.
If it wasn't on Captain Kangaroo, I think it was on the same channel, CBS, I suppose.
Probably, because Captain Kangaroo, they played, during the Captain Kangaroo show, they played Clutch Cargo. And Clutch Cargo was this animated, it was a cartoon, but the mouth was a real person's mouth doing the talking.
I remember
And it
that.
was superimposed. It really looked bad. You know what? It was bad TV, but it was all we had.
Yep.
So okay, so now let's see here. Oh, that's the nucleus of the comet. Keep in mind that the filter makes this look blue and it's really kind of green. All right, but it's really just a beautiful core. And you know there are some things you can find by looking at these things up close like this. A lot of, I mean, I have a spectrometer actually, and when the next telescope, which is behind me, goes in, the spectrometer is going to be active on that. So we'll be able to look at it with cameras, like we're doing tonight, and we'll be able to take a spectra of the comet and see what cyanogen actually looks like in the spectrum of a comet. I can't wait. That's going to be really cool. Really cool. And I've done a lot of spectral work, so it'll be not easy, but it's going to be really, really interesting to show you what's really going on inside of a comet. You know, and not just comets, but nebulae of all kinds. Wait till you see the Orion Nebula with a spectrometer. Oh my gosh. Well, the things that are going on in there, it tells you exactly what it's made of. It tells you the temperature. It tells you how far it is at some points. It tells you whether it's running away from you or coming towards you. You can actually figure out a lot of things if you actually reduce the data and you get really good data. So let's go back to this. And I'm going to drop down because I'm trying to catch just the slightest hint of the nucleus. So we're going to go and actually I'm going to drop this down way down low. It's this I should have been dropping down. So we'll go to 800 and bring this back up to like, we'll do 4 seconds, no, 6 seconds. 5 seconds? Okay, good. So we'll do 5 seconds at 800. We want to see the nucleus of the comet down here. Okay. Let's see if I can see it. Let's see here. Okay, there it is. And let's move it over and zoom in. So you can see, this is what I wanted to show you. You can see the evenness of the coma around the comet. The coma is the cloud around the center of the comet. This material is being excited by the solar wind, and the outgassing is occurring relatively evenly on this comet at the moment. And so you see all this material being gassed off the comet like this. We're not seeing, you know, a core of the comet. It's only 3 miles across, so it wouldn't even be at this distance. We'd never even see the size of it. It's smaller than the smallest amount of noise on the screen right now. But all right, well I know that's relatively kind of boring. So what I'll do now is take us down another path as I was doing before, but this time we're gonna go the opposite direction. We're gonna go very high on the ISO. We're gonna go to 20,000, not 25.6, 20,000, and we're gonna do a 10-second photo. All right, and let's see what we can do. Now we're doing this again with the filter number 2, which is the kind of wider narrowband filter. A narrowband filter is looking at different slots in the spectrum, and this is going to give us a wider view. Okay, so there's the wider narrowband view of the comet, and it looks really cool. That's pretty neat, huh?
It is.
Look at that. And you can see this tail here. So some of this is dust tail, but the stuff going straight back like this, that right there, that's the gas tail that the filter is pulling out for you. The dust tail is kind of up here and heading off to that side a little. This straight back is the actual ion tail, as it's called, or the gas tail. It's excited gases. They're so excited to see us. Wow, that is very cool, and I love doing this for you guys. Okay, let me let's go back to, actually, you know what I'm gonna do? I'm gonna do this. Let's go to our narrow band filter, and it's gonna let in even less light. And let's see what this same shot shows us with the narrow band filter. I mean, that's kind of cool. Why not, right? Let's do that. So 10 seconds at 20,000 with the narrow band filter. The narrow band is the most small bands allowed through. The wider band one has little pass through of wider bands around the target frequency. Okay. And this will give you an idea just how much a narrowband filter really does allow in. And you'll say, why do you use it at all? Well, we use it at all because of the fact that the narrowband filter is great for nebulae. And just the filter alone on this telescope was extremely expensive. But they're needed because without them, you can't do certain types of photography, you know. So I think that it's pretty interesting. Daryl, did you want to talk to David Schmidt's question? Oh, I think he's actually making a statement. Sorry.
Yeah.
Okay, yeah. 17,000 miles an hour. I mean, that's the speed, that's the speed at which the ISS goes around the Earth, right? 17,000 miles an hour. 17,500 miles an hour. So it goes around the Earth about 15 to 16 times a day. So that tells you how far. That's 25,000 miles every 90 minutes. 25,000 and change. So if you add those all together at 17,000 miles an hour and look at it for like a whole day, you can kind of get an estimate of how far in space the comet might have gone. Because at the distance around the Earth is 25,000 roughly miles. Then you can actually see that the distance of the comet moves is pretty impressive each day. And we're watching it move literally dynamically. It's really impressive. Farva, man, thank you. You know, you know what? You're the man. You're really good, you know. Ships and giggles, I like that.
Slow down, Farva. It ain't the end of the month yet. You're going to be eating cat food if you're not careful.
Yeah, well, we have good people that support us, you know.
Mm-hmm.
We really do. All right, let's go back to this guy. And
Mark, would you excuse me for just a moment, please?
go right ahead, Daryl. Okay, what I'm going to do now is I'm going to take us back to. Well, I'll show you this. I'll show you this next one. Okay, this next filter is going to seem strange. Okay, it's just sort of a little hint as to what's to come, and I'm going to do 15 seconds at 20,000. This filter is our spectral filter. It's really kind of a shotgun approach. It doesn't show everything. Okay, it actually shows kind of globally what's going on in the comet. And you're going to see when it comes back here in just a few seconds. Okay, this here is very telling what we're seeing here. Okay, this object right here, this is a spectrum, okay, of the comet. Here are the spectra of the stars that are in the same field. Excuse me. All right, water. I actually drank water for the first time since I started the stream. Okay, what we're looking at here is we're looking at the spectrum that this comet has left. This is right here. This is the very, very small spot that is the nucleus. These two here, these objects here, this, in fact, we call this the zero order spectrum. Get a zero order location for the spectrum. So the comet's nucleus is right there. But this here, this green is actually showing us the cyanogen directly in the spectrum. All right. And then this here is showing us the dust from its spectrum. Now, the way that the dust that we see coming from this comet, this dust is actually going to be reflecting the sun's spectrum. So we're going to see that buried in here if we look, right? But we see the cyanogen in here, and with the spectrometer, once I get that running, and it's right down there in my underneath my drawer here next to me. This we're going to see this in more detail. We're going to see the exact how the spectrum looks. And it's going to just be very stunning. I can't say enough. I'm trying not to give it all away. But anyway, hello, Susie Cat. Nice to see you. So that's the a quick view of the spectral readout. But we're actually, that's just, again, it's a visual. We got a lot more planned. We got a lot more capability coming up. So now what I'll do is change this back to our filter that is the pass-through. And you'll notice this nucleus gets very bright coming up right about now. Okay, so now we're looking at it in visible light again, so you can actually see it looks a lot brighter than when we had it under this guy. Okay, this next one here. All right. In fact, you can't even see it in this view, but it's actually still right here. But this is the narrow band. Now, if I go back one, you'll see it show up really bright. There it is. Okay. So let's take another shot of this. This is 20,000, 15 seconds. Let's go to, let's dare to go to 20 seconds at 20,000 here. And let's take a look at not only where that star is, okay, but where the see, the star is like here, okay, and this is the spectrum one. And now when we come back, we're going to see where it is relative to that star. Well, there's that star. Look at that. It's gone quite a distance, hasn't it? Oop, you can't see it. There it is. It's going quite a distance. I'm going to figure out what this is. This is some sludge that's actually in the optics, and I can't find where it is. I tried finding it today, and I couldn't find it. I really don't want to have to take apart the optics. This is a new system, and this should not be there. So I'll figure out where that's coming from and get it the heck out of there. But look at that. So now, you can see more sometimes when you zoom out. So you can actually see the entire, a little more of the tail here. But that star you see is there. And it was, if we look back at the other, others, let's look here. That's where the star is, right there. Okay. Now, we now look at where it is now. Okay, watch this. The star is there. And where is it in the next shot? Oh, look at that. It's right there. That's quite a difference. Quite a difference indeed. So it's actually really, this comet's really moving through the sky. You know? And just keep in mind that the image was like this. So it was there, and that means that the comet's actually moving relative to the camera, right? This is how it actually looks to us now in the sky. Okay, so the tail goes this way, but we're showing it to you this way so you can actually see it. Okay, but the neat thing about this is that this is you can see this motion so clearly. This is making me crazy right now. Oh, I can't stand that. I don't know what that is. I gotta get rid of it.
It's a bug.
It's not a bug. I actually don't know what it is. I tried finding it. I was telling people today, and I couldn't find it. Really, really bothered me. Okay, I'm going to move us up a little. Get it out of my... If I don't see it, maybe I won't... it's not going away, obviously. But let's just do this. Okay, so 20 seconds. Let's do... no, let's drop down from 20,000, 16. Let's do 12,800 for 25 seconds. So we drop down 2 stops, increase 1. It'll be a little dimmer. Here we go. Farver, you know what? You're you humble us with your donation. That's very kind. And the other night we had a number of people donate to us as well. It was very, very kind as well. With everything going on with COVID right now, I would not have any problem and don't have any problem with people who just can't afford to do that right now, and I'm okay with that. If you like the stream, let us know with a thumbs up. If you still want to donate, I'm humbled, thank you, but I'm not expecting it. I'm not going to stop doing this if you don't. So you still get the show, You still get the show anyway. Yeah. So, that's just really pretty, man. Really, really pretty. Let's see. Let's just bring up the planetarium for a sec. Yeah, we're actually in the realm of a couple galaxies too, right there. Let me also, while I have this here, let me do something else. I'm going to record where I'm located, because I think that the unfortunate fact is that the Sky Live is actually behind on its calculation.
I was wondering that the other night. I was looking at Sky Live. I don't remember what it was, but something made me wonder how accurate it is.
I think it's not as accurate as we had hoped. That's okay.
Yeah. I know their magnitudes were off.
Yeah. You wondered that several weeks ago, actually.
Yeah.
Thanks, Dagger. That's very kind. I mean, I can be a jerk sometimes, well, sometimes, maybe. But I don't endeavor to be a jerk. If I don't eat, then I am a jerk. I forget to eat, by the way. That's another problem I have. I forget to eat. And I will say that the lifestyle change I made was, I started in the morning, I would drink water. And I drink water all day until evening when I have an actual meal. And I just started doing that. And every now and then I'd have a little snack, maybe some pretzels at noon or 11 o'clock in the morning or something. Just a little tiny snack, nothing huge. And I discovered something. I discovered that I don't need to drink soda anymore. I discovered that weight just melts off. If you saw me before, maybe a couple months ago, then you would have seen someone who's almost 200 pounds. And now I weigh 179. I'm literally 4 pounds from my high school weight. 3 pounds from high school weight.
Yeah.
That, I didn't know that you could do that. So I'll say easy, but the first 3 days are tough. But after that, it actually goes much better, Daryl, I had to
Now,
go ahead.
huh?
Go ahead.
I'm sorry.
No,
No,
go
no,
ahead.
go ahead.
No, you go ahead.
Oh, I
Chippendale
was
here.
just going to say, we've talked about this before. Some people call it intermittent fasting. It's supposed to do all sorts of good things for you too. Supposedly wakes up your stem cells, helps stem cell regeneration,
Yeah,
which goes out and addresses various injuries and inflammations in the body and stuff.
yeah. I can, I can, I can sympathize with that. I can see that. And
Yeah,
I will say that the amount of energy that I have is just exponentially more. Uh,
good.
yeah, no, it really is, And for those that
Yeah.
know me, like what was it 5.5 years ago now, Daryl? I needed heart surgery, right? I had to get two valves fixed because I had infection in my heart valves.
Wow.
It kind of went sideways, and when I came out of it after the surgery, I was profoundly blind. I was a quadriplegic, and I had to learn. Actually, the surgeons and the neurologists said that there was no way I was gonna see again. No way I was gonna probably walk and maybe talk, but because I couldn't do any of it, and so I really didn't know if I could, but I knew that the brain is a very, very powerful organ, and I felt that it could heal itself if I just gave it what it needed. And I made that decision to put my money where my mouth was, so to speak, and commit to feeling pain so that I could train my brain. So I came up with this little mantra: train the brain with pain. And I couldn't see it all, nothing. And here's what's interesting. Again, the human species is really quite highly evolved because it has a way to cope with things, and it has a way to fix things. And medical science is a little behind on this, and I'm convinced. And one of the things that the brain understands is pain. We evolve so that we don't want to feel pain. We actually evolve mechanisms to avoid pain, right? Let me see you hold your finger in a burning candle. Ow, you pull your hand out right away. Okay, that's an evolved reaction, an evolved stimulus reaction. You feel the pain and you back away. It's a natural reaction. It happens throughout all the animal kingdom, all right? And it happens to cells on a cellular level. Cells will retract as well. So if you think about this, what's really cool is that if you can train the brain to react to pain by trying to get the body out of there, trying to figure a way around it, well, then to me, I was in a coma for a week too, and during that coma, I was wide awake. And no one believes me, but I relayed all the conversations, and they're scratching their head going, "How's he know that?" Well, 'cause I heard you. I was right there, as lucid as I am now. And what I discovered was if you could stimulate the part that wasn't working by forcing it to work and forcing it to be involved in something, then the brain is going to say, I can't stand this. I can't stand this. I got to find a workaround. Example, my eyes didn't work. All I saw was like this screen here that we're looking at. Imagine this kind of view. Imagine it kind of dark gray and no variation. If someone was right in front of me, shining a flashlight in my face, this is what I'd see. Okay, but smoother. Well, anyway, I said, okay, my eyes have to work. I've got to keep. I want to be able to see the universe again. I contemplated not being able to ever see the night sky again, and it just wasn't going to work. Okay, it just wasn't going to work. I didn't want it. So what I did was I had the nurses, because I couldn't talk either, so I had a trach for a long time, and they had to take that out. So on June 15th of 2015, this is when this was, I was brought to the rehab hospital after the surgery, after they got me to the point where they could transport me. And in the rehab hospital, I had the nurse put my laptop, after they took the trach out, it was like 3 or 4 days later, and I said to her if she could put the laptop in front of me and have it going. And she said, well, you can you see? I go, no. And she goes, well, what are you doing? I said, I'm gonna make my brain see. Okay. Anything, hey, if it works, great. No one had any faith it was going to work, actually, because the eye guy there said, you're profoundly blind. There's probably, maybe you get some of it back. We're hoping to get 10%. Maybe you get some shadows. Maybe you see some shapes. Because my brain looked like Swiss cheese. Because during the surgery, the reason this all happened was a clot got away from them when they were fixing that. And when it got to my brain, it exploded into millions of pieces. And it made 6 to 8 separate major strokes throughout the brain. And my family was told I was probably not going to make it, and then I did. So they tried to prepare everybody for that. But I heard all these things. They were talking to my family when I was in the coma, and I could hear them saying, you know, at best he'll be a quadriplegic and blind. You better prepare yourselves, prepare your house, etc. And I heard gasp, gasp, gasp. Over on this side and over here, there's this neurologist saying these things. And I'm thinking, no, you're wrong. I'm going to see just fine. Well, anyway, I went to, at the eye doctor at the rehab hospital. I ended up, I'm doing another shot here too while we're here. Ended up being able to train my eyes again. And the way I did it was when the nurse put on the laptop, she put a show on Netflix, and it was right in front of me, and I could feel the heat from the screen. It's interesting how quick other senses take over to try and feed you information when some of them aren't working. And I could feel the screen's radiation hitting me in the face, right? And so I got as close as I could to the screen. I couldn't move. Okay, I had the nurses move my, oh, this is pretty. I had the nurses move my table closer. And so I could feel it. So I was literally right on top of it. The laptop was like hitting me right in the neck almost. And it took 2 days. Okay, guys, it took 2 days. And in that 2-day time, I went from seeing nothing at all to seeing rough shapes. Because the brain was struggling to make sense of what was on the screen. I had migraine headaches. My eyes were, just literally running water because it was so painful. I wouldn't take my eyes off the screen because I knew that the pain is what the brain tries to avoid. It's what evolved the human being to recoil from flames and things like that. I wasn't going to recoil. I think that the brain needed this. So when I went to the eye doctor that following week, I asked him to put the eye chart up, and he goes, what? I mean, he almost thought I was being funny. And I said, no. I said, let's just see if I can see it. He puts it up, and you know what? I saw a white square on the wall, the white square. I couldn't see the figures, the characters on the wall. But I said, okay, you just turn the light on. I see the white square. And he goes, he was a foreign guy. He says, that's right. You see that? I go, yeah, I do. I said, next week I'll be able to read those letters. And he goes, really? I'd just be amazing. I can hear him scribbling furiously. He says, and it seemed like a lot of doctors all said this. They said, I've been doing this for X number of years, and I've never seen this type of recovery. And I said, well, it's not me, okay? Anybody can do this. Anyone can do this. You just have to know what to do. I said, this came to me in my coma. When I was in the coma, I was formulating a plan. I was actually writing a circuit that doctors could use to plug into my brain, and that circuit was intact, and I just had black boxes where I didn't know what to put in. And I'm not a doctor, but I knew how it worked. I don't know what it was. It just seemed so clear to me. And in the coma too, I might have told you this. In the coma, I actually had perfect recall of every moment in my life. Perfect. I can remember when I was 3, 5, 10. I can remember all kinds of things that I did. And then when they were taking me out of the coma and my body was reconnecting, my circuit was fading, and the pain in the rest of my body that was now being generated, the buzzing in my head, it was so bad that I was screaming, put me back, put me back. Okay, I want to be back in that other place because I actually was getting something done, you know. And anyway, as it turned out, and I'm a science guy, so this stuff was really kind of new to me, you might say. When I actually started getting my eyes to work again, the second week, I got there June 15th, and the doctor, Shafisik was his name, he looked at my eyes, said profoundly blind. The next week, he was amazed that I could actually see the white square. The following week, okay, it was like June 25th or so, maybe 24th. I read the characters in the first two lines, and I could actually see his face, and I saw his mouth like this. he was like, and he goes, you see that? I go, yeah, yeah, I can read it. It says ape otf, APEOTF. That was the first line. He goes, that's right, and he said, this is incredible. I don't know how this happens. I said, I tell you how it happens. You got to tell other patients this because it's going to save them. I mean, it's going to save parts of them and bring some of the stuff back that's missing. So he ended up writing a lot of notes. I don't know if he does. I mean, has done this, but I've talked to neurologists and people, and they just don't believe that the brain works this way. They're just so stuck in their dogma. But see, guess what? When the doctor came in to see me, my regular doctor at that place, he says, and this is the doctor that handles a lot of patients there, and you can understand he doesn't see a lot of success. And he said to me, we want you to know, you're going to be here 8 to 10 weeks. This was like June 15th when he told me that. You'll be here 8 to 10 weeks, and it's probably going to be a 2-year recovery. We're hoping you get maybe a quarter of your, 25% of your functionality back. Maybe you'll get more, but your brain had quite an assault. And I said to him, I couldn't see him yet at that point, and I couldn't talk either. So what came out was like baby babble, like okay. But I learned how to do it again really quick. And then when I said to him, I go, Dr. Soltis, his name was Dr. Soltis. I said, Dr. Soltis, I have to be in Los Angeles in September. It was June 15th or 16th. I have to be in Los Angeles in September to do a talk at a conference. And I heard him audibly gasp. He went, ah. And then he said to me, Mr. D'Antonio, are you fully aware of what happened to you? I said, yeah, I had some strokes, but he came out with, I had some strokes, And he goes, yeah, we're going to help you as best we can, but and again, they always pull that rank. I've been doing this for 35 years, and they take as long as they take, and that's what happens. I said, yeah, but there's other ways to fix this. He goes, well, more power to you. If it works, great. And he was kind of dismissive. Well, now, by June 24th, when he came in, he was noticing that I was now walking on a walker. I wasn't very good at it, and I was just so beside myself trying to get down the hallway. I still was trying to see further, and make my brain work. And the walker actually is your support structure. And if you don't have it in front of you, then your brain goes, oh no, I'm going to fall. And guess what? That's exactly what the brain needs to actually heal. I'm not recommending that people do this, okay? Trust me. The brain has to think there's real danger for it to jump into overdrive and heal itself. And I did just that. It isn't for everybody, I'm sure, especially if someone's older. I can't imagine them trying this. But I was 55 at the time. I'm 59 now. And I basically, I took the walker, and when my arms were working enough, I pushed it out in front of me, and now I was all alone on the floor. And it was about 4 feet ahead of me. 4 feet ahead of you when you can't really walk might as well be 100 miles. And I could barely see the walker, and I could kind of see the edges. And when the nurses saw me push the walker, it's like they came from all directions yelling, oh no, what are you doing? And they'd come and they'd bring the walker back. And I said to them, no, you got to let the brain feel like it's in danger in order for it to actually jump into overdrive and fix itself. I said, it's train the brain with pain. Of course, it came out, it didn't come out right yet because I still couldn't talk. So I went through all that, and by the time June 30th rolled around, I told them I want to go up a regular flight of stairs, and they only had me going up 3 wooden steps in a special gym with a harness off my back to the ceiling on a special line. So if I fell, I would just dangle. Ooh, wow, I'm a puppet. I said, no, I can't have anything helping me. I've got to think I can fall. The brain has to know that. The brain has to sense fear for it to actually work to repair the problem. You're coddling people too much. They've got to be in danger. I hate to say it that way, but they've got to feel. The brain has to feel it's in danger. They don't have to really be in danger. I convinced them after a full day to let me go on the staircase. And you should have seen it. It was like a freak show. They were behind me, on the side of me, using their knees to push into my back of my legs to make sure they're blocking me, as they called it. And I said, no, you can't touch me. I know what you're doing. I appreciate you very much. You make the world go round and you fix people who are broken. I totally get that. But I have to feel, my brain has to feel there's real danger. So do all of what you're doing, but don't touch. Okay? Don't touch. I'm not afraid to be touched. That's not the point. I just need the brain to say, I'm all alone here. And I didn't look behind me. I didn't want to. I wanted to look just straight ahead. I'm looking up the stairs. My brain, walking up the stairs, I felt like I could fall backwards. I felt like I might fall. That causes the brain to just like muster all the adrenaline and the support and start forging pathways. If you don't forge a new pathway, you're going to die. And that's what works. And that's why I'm here today. That's why, because now July 1st rolls around and the doctor comes in, and I look to the door and I see him walk in. I say, hey, Dr. Stoltz, how you doing? And he goes, you can see me. I go, of course I can. I've been fixing my eyes. He goes, I don't know what to say. I go, well, tell me what you have to say. He comes over and he says, we're really amazed at your progress. I don't know how you really did it. I said, well, I tried to tell the eye doctor and the neurologist that this is not something that is just particular to me. This is something that all people can do. All people can do this. They just have to accept the fact that they have to embrace the pain. If they don't embrace the pain, then they're going to just say, doctor, give me a pill to kill the pain. If they don't embrace the pain, it doesn't fix itself. The brain has to hurt for it to rebuild the pathways. It has to hurt badly, especially when you can't walk, you can't talk, you can't move. If you want any of that to come back, you've got to embrace the pain. If you don't do it, you're not going to survive it. You're going to be in a wheelchair for the rest of your life. You'll be a vegetable. Now, that's in particular cases. Obviously, traumatic brain injury, very, very different story. Okay, but with pathways that are disrupted by clots in the brain, that's something that I think is fixable. Why? Because I've seen it done. I've actually talked to other people, and I've actually helped other people fix their issues.
You helped me, Mark.
Well,
I don't know if I told you that or not.
Yeah, I wasn't going to tell your story, Daryl, because that was private to you. I didn't want to say that.
Well,
but
yeah, I'd rather keep it that way.
Sure.
I can say just in very general terms. Mark described some exercises to me to push the envelope, so to speak, or push the pain envelope, whatever, and they worked. And I'll just leave it at that.
Well, you have no idea how good that makes me feel, Daryl.
Good, good. I mean, and I've got a ways to go yet, but I have improved tons.
Well, I'm very happy you have. I mean, this is, you know, people's personal trauma they go through, and the personal war that they're fighting with their own body is like, it's the worst, because people don't know sometimes what they can do to help themselves. They don't know, and I didn't. I felt there was only one way, and there was only one way was to actually the way to do it was to embrace that pain, because that's the only way that you're going to kick that brain into overdrive to make it work. And that was kind of how I felt. I'm very happy to hear that it's worked for you. And Daryl's not the only one. There was several other people actually that were in very sad shape, that have had strokes and were paralyzed. And I just told them what I did, and I was very surprised. One time I told one particular person this, and when he asked my advice, what did you do? I'm like, I feel like I am not a doctor, but I will tell you what I did that worked for me. I told him what I did, and several weeks passed, and then finally in the SkyTour LiveStream, he shows up. He's in the stream. Look at the trees, look at that. And he writes in all caps, "Everything you said came true." Wow. I mean, is there no better proof? That's just outstanding. I was so blown away by that. And that gave me the confidence to actually start talking to other people about it. It's why I tell you about it now. And we had Daryl's recovery. We have this other gentleman's recovery, and other people I've talked to. The medical community just has to stand up and actually listen. On the day that I was discharged from the rehab hospital, and I'm sorry I'm going down that path during the stream. If you don't like it, do a thumbs down or something. I understand. But on the day I was released, it was, remember, I went in there June 15th. I was supposed to be there 8 to 10 weeks. 8 to 10 weeks. And the doctor came in on July 2nd. Okay. And he says to me, "We're sending you home tomorrow." Really? Yeah. He goes, "I can't explain it, but you have gone far beyond any abilities we have to heal you. You've healed so fast that we don't know how it happened." I said, "But I've told you how it happened." And by the way, when I was talking to him now, I was speaking correctly because I had fixed my voice too. How did I do that? I had the nurse give me a mirror. After I got my hands back, I made my hands work too. There's a whole process there. I looked at the mirror and I watched my face when I was trying to talk. And I saw where my mouth was going wrong. I said, "Well, that's not right." So I would push, I didn't have full control of my fingers. I pushed my face in the right direction and say, "Okay, that word, to say that word, I have to have this over here." And I actually started talking, weird like that. So much so that the roommate I had complained, and they moved him out of the room because I was keeping him up at night. TV on 24/7, my laptop rather, watching shows that I couldn't see, and then I started to see them, and then I could see them. The eyes, by the way, total time it took to get the eyes back was about 2 weeks total. 2 weeks from profound to being able to see like I see now. Absolutely amazing. The brain is plastic, folks. The brain is plastic. And you know what? Bringing us back to SkyTour LiveStream, we have comets to thank for a lot of this, by the way, for our abilities. Because the comets are carbon bigots, like I told you. They're full of carbon compounds. Many of that carbon that we see in comets has ended up here on Earth because of the nature of the carbon compound structures in comets. We find that, in fact, carbon bonds with more things than any other element in the periodic table. What does that mean? Well, we call it sometimes the granddaddy of all elements, but it means that the carbon compounds are the most flexible. So when you're healing your brain, are you not forging new pathways? What does that mean? It means you're creating new carbon compounds in your brain to circumvent the bad areas that aren't working and build new pathways with new carbon compounds that will now allow you to do what you got to do, like, roll quarters down your fingers like I do, roll them down my fingers, and that was a different exercise. And play my drums to learn coordination between hands and feet again. Play the guitar to learn how to get my fingers working again. These things are also very important. And I think it's really important for everyone to understand that, all of the abilities we have, they basically come from these guys we've been looking at all night. So all this blathering on that I've been doing, okay, using this, this comet has reminded me about all this stuff, okay, because all the carbon compounds we see there were delivered here by asteroids, comets like this one, okay, here, and by meteors, and made by the Earth itself. And life based on carbon has this flexibility. It's pretty stupendous. We are pretty stupendous species. And without comets, these natural interlopers in the universe, guys like this right here, if we didn't have this type of interactive object in our universe, in our local universe, in our solar system, we might not actually be here. See, the comets are the ones that actually brought us all this material from which we developed and from which we learned how to manipulate our local universe. So it's pretty interesting indeed. And I've never grown tired of doing what I do. I think that it's just amazing to see this stuff. It's incredible to explore comets and every other object out there. And I think that, and crazy, Susie Cat, you say something pretty interesting, because I've also said this to neurologists. Okay, when we look at how the brain has worked to repair itself, and we say, well, the brain is plastic, right? It's changing. Neurology still doesn't quite believe that. Some of them do, but many of them do not, and they don't believe in the ability of the human body to heal. All right, but if you look at the ubiquitous carbon atom, the carbon atom's capability of changing up its bonds, it can take a single compound, okay, all right, called an isomer, right? It can take a single one of these, and it can make a variation of the same one, all right? In other words, a different configuration. I talked about this at the beginning of the stream, and that's called a tautomer, Tautomer, and it's the same relative compound, all right? And that tautomer might react a little bit differently. So maybe what we're doing in our brain with its, when we saw it, let's say it's plastic, maybe what we're doing is we're modifying the carbon compounds to act differently in our brain, and this could cause the healing to take place. And when that doctor walked in, and I had told him in the beginning, and he kind of, poo-pooed me. He gasped when I said, I have to be speaking at a conference in September, which is just a few weeks away from when I got into this hospital. I couldn't walk, I couldn't talk, I couldn't move, okay, couldn't see. He walked in on July 2nd to discharge me, and I saw a big smile on his face. And he goes, you know what? I really think you're going to be at that conference after all. And I was. It was sort of a surreal experience. I'm walking through the lobby of a hotel in Irvine, California, September 19th, 2015, thinking, I'm here. I made it. And I can talk, I can see, I can move. And I've never really looked back, but I think the important thing here is and going back to Susie Cat's comment earlier about electrical circuitry. I said to neurologists, I said, we don't need neurologists, we need biological electricians. Okay, biological electricians. because that's what's going on in our body. We just need bioelectricians to work on our body. You know how your electrician hooks up a light in your room, okay, in your house. We need guys to do that for our body. Oh, that part of the brain doesn't work anymore? Okay, well, let's put a new circuit in. Let's put in a new circuit. That ought to work, you know. And I think that's something that can certainly happen. We're just not quite there yet. Maybe the way we'll do it is with nanotechnology. Now, as many of you know, I wrote a book called The Populated Universe. It's about the hunt for extraterrestrial life and exoplanets, because as an astronomer, that's what my degree's in. Exoplanets were the specialty I chose after getting my degree. So I've been going down that exoplanet path primarily because I'm very interested in seeing what carbon-based systems like comets can do to other worlds elsewhere. And it's kind of interesting that Tabby's star, Tabitha Boyajian's star, that seemed to be dimming up to like 22% at times. They thought maybe it was actually a swarm of comets that are slowly orbiting this star. But comets are transient objects, especially when they get like this one here. Okay, they do evaporate at some point. This comet will be back in 6,800 years, and it's going to be smaller than it was this time around because it evaporates over time. That said, this evaporation it couldn't account for the timing that we look when we look at Tabby star. So obviously these couldn't be a swarm of comets. It didn't make sense. Now they think it was sort of maybe an interstellar dust cloud that may have been between us and that star. And of course, there's the other theory that maybe it was an extraterrestrial civilization that is creating a Dyson swarm of satellites around its home star to gain energy. And if that was the case, that is something. That'd be something to take note of, right? It might be the first indication of an extraterrestrial civilization. Astronomers are very slow to react to that. I speculate, much to the disdain of some of my colleagues. When I wrote my book, the book has lots of speculation in it about extraterrestrial civilizations, how their progression goes, what can happen to them over time. We talk about Easter Island. Hey there, Gina. We talk about Easter Island and how that was an isolated civilization for a long time. Easter Island is to Earth like Earth is to the universe, right? Easter Island, they ran through their resources, and they ended up becoming a civilization in steep decline. And many of them left the island to move to the mainland of Chile, okay? And many of them died from war and disease and other pestilence. And it happened primarily because they were warring amongst themselves, eating all the resources, not planning for the future. Sound familiar? We've done that here on Earth, and we're doing better. We're doing much better. I have a feeling we're going to become a Kardashev civilization, type 1, maybe in 100 or 200 years. Michio Kaku will agree with me on that. And I think that what we want to talk about is what are we going to do after we're a type 1 civilization? That means that we use renewable energy. We don't use fossil fuels. As he even said, scratching his head, we still burn dead things for our energy. I mean, you're going to run out of dead things. And that's true. That's true. So we have to convert. Yeah, I mean, I developed windmills for the Gulf Stream, believe it or not. And I don't know if I talk about it in the book. I think I talk about it in the book too. Gulf Stream windmills that would actually rotate so slowly that a whale could just go right through the blades and not even get hurt. Submarines could go through there, and the blades are fabric, so they would actually just drape around and then come off. But they would actually slowly turn this turbine that would send lots and lots of current to the shore. And it takes you have a number of those turbines that might actually be capable of doing an awful lot of energy generation. I developed other things too Solar power is great, but solar power is limited right now because we need surface area. Surface area. And so, thank you, Farva. My gosh. And so, when you look at the surface area of solar panels, we need higher efficiency solar panels. Right now, the highest we can get is above 40%. But the general one that you get are around 17 to 20%. That means that's how much energy actually gets converted to usable electricity. Most of the rest of it gets lost as heat, and it's not absorbed. So solar is one thing, but guess what else is always going on this planet? Yes, wind. I know some of you are thinking wind, but what about oceans? And Susie Cat, man, you're right on top of things today, man. This is great. Wave power never ceases. You know, I developed a little bobber thing that could go up and down in the ocean and just make energy all day, all night, all the time. A hurricane comes, hey, more energy. Wow, hey, okay. So, and there are bobbers out there, bobbing devices that do this, but they're in testing. They're not deployed in gigantic fleets, so forth. You could anchor these things to the seabed in shallow water, like 200 or 300-foot water, and the long, gentle wave action reaches down that far. You'd never see them on the surface. You'd never interfere with shipping. You'd never interfere with people. And these things could just bob and weave down below, okay, as the ocean rises and falls. Keep in mind, water is not compressible. So as the wave goes up on the ocean surface, okay, the whole water column is going to go up and down, okay? The whole water column is going to go up and down. And if there's a bobber down there, it's going to be lifted and dropped as the ocean rises and falls as well. So I think that's something that we could use, and we should, you know. So that's using renewable energy, and the energy of the sun can be gained in other ways. Solar panels are great, but maybe we could actually put a bunch of satellites around the sun, thousands of satellites, and they beam their energy to collecting stations in Earth orbit. And that energy is beamed via microwaves, gets to the collecting station, and then is beamed down to the ground stations where it's actually distributed and utilized. Endless energy never stops. You know, if we had as many satellites that were doing energy generation or energy collection as we have GPS, or as, you know, Elon Musk has, the Starlink, well, then we would probably end up having a planet that is on its way toward energy independence. And if everybody had access to energy, you know what else is going to stop? Wars, you know, to some extent. There's always wars of ideology, but the wars will stop. You know, from that comet's perspective out there, it doesn't see a planet that's warring. It sees a pale blue dot, as Carl Sagan says. And that pale blue dot needs to be unified if we're going to ever leave here. And we have to. We all know that. When the sun runs out of hydrogen, it's going to swell. Our comet, by the way, has gone below the horizon. Not below the horizon, but below our local horizon now. It's down in the trees. And we watched it actually to the point where it went down in the trees. Our last photo was right here. And there's the comet going down behind the trees. So this will end up concluding our stream tonight, because NEOWISE was it. NEOWISE is all we're doing tonight. And I did want to thank all of you for coming out. And, leave me a comment. If my stories are too much, I'll go down different paths. If you want me to talk about some more science, I can do that too. But I just think that it's all, I think that's all pretty much all related to what I went through, is related to that guy on the screen right there. Okay. The abilities we have are related to that guy on the screen right there. And not that particular one maybe, but the ones that have hit us over the years. Let's see now. Genghis, he asked a question. How about satellites to boost Mars' magnetosphere so we can work on its atmosphere? Yeah, Genghis, remember we talked about that for sure, yeah. And Amanda Curran, of course our co-host, likes to talk about this. You know, if you think about Mars right now, Mars doesn't have much of a magnetic field. And the reason is because Mars' core isn't creating a dynamo effect like the Earth's. What's the dynamo effect? Well, you have a solid inner core because of the pressure on top. Okay, the pressure holds it solid. It's iron, it's nickel. Iron is a ferrous, magnetic, material element. Outside the core, where the temperature is a little less, and the pressures are a little less, we can have a molten core. That molten core is sort of sloshing and moving around as the Earth rotates. It sort of rubs against this solid inner core, and that rubbing motion creates electrical discharge, and that electricity creates in turn a magnetic field. The magnetic field of the Earth encompasses the entire planet. That magnetic field also protects us from the sun's ultraviolet energy and from high energy charged particles called the solar wind coming from the sun that can kill us. Now, how does it do that? Well, because the high-powered protons and electrons that are coming at us from the sun are the solar wind, and that solar wind is, thank you, Farva, my God, you can't stop it. I don't know what to do. I really appreciate it, though. The solar wind, these are charged particles. And when they get to the magnetic field, charged particles will often interact with magnetic fields. And so when the magnetic field lines encounter these particles, they get trapped by the magnetic field. And what they do is they spiral down toward the north end on the south end of this magnetic field, the north and south pole, magnetic pole. And they create the interactions with the atmosphere that we call the aurora borealis, okay, and the aurora australis, the northern and the southern lights. And they also, these particles get trapped everywhere else around the Earth in this magnetic field. And that trapped set of particles becomes a radiation belt around our planet. That radiation belt is known as the Van Allen belts. Okay, and these Van Allen belts are can be very powerful at times, and sometimes so powerful that astronauts have to retreat from certain modules on the ISS to go to more shielded locations as they pass through sometimes a lower altitude Van Allen belts. I can't remember if that was over the Pacific or the Indian Ocean. I don't know if you remember, Daryl, or not, but they were somewhere over there, in that region. And in any case, so that magnetic field is very important. So at Mars, because there is no dynamo, that core shifting around the inner core like that, like on Earth, the Mars magnetic field doesn't protect its atmosphere, as ours is protected by this magnetic field. So these high energy particles strike the atmosphere and strike all the way to the ground, everywhere, and they destroy water molecules. They rip apart young compounds that are being formed in the soils to possibly create further compounds to thicken Mars' atmosphere and raise the pressure at the surface from the thickening atmosphere. And so Mars' atmosphere is held at just about 6 millibars, which is really very, very small compared to over 1,000 millibars here on the planet Earth at sea level. So we have to say that we have a ways to go if we're going to increase Mars' atmosphere. But how can we do it? The way we can do it, and this is a NASA project that's on the books, okay, that they want to do, we can do it by putting a satellite at what's called it's a parking spot in space, basically. It's a Lagrange point, it's called. And it's on the side of Mars toward the sun. And we'd have this little satellite out here, and then we'd have Mars on the other side of it, and the sun beaming toward the satellite, and the satellite between the sun and Mars. And the satellite would be generating, or a set of satellites in this parking spot would be generating a magnetic field. And what happens when solar wind hits a magnetic field is it causes it to drape. And it would, if we can make it big enough, magnetic field, we can cause it to drape over Mars. And Mars will be caught in the tail of this magnetic magnetosphere that's being generated by the satellites. And that magnetosphere would protect the Martian atmosphere, and it could grow once again, because oxygen's being generated on all the time on Mars. It's just being it's just that it's being destroyed by the what's called photodisassociation with the ultraviolet light that's striking the surface. But if it can't get to the surface, then water vapor and oxygen that's created will stay in the atmosphere. The atmospheric pressure will rise, and then that'll make it even harder for the ultraviolet radiation to get to the ground. And so it begins a cascading effect where maybe we'll have a runaway greenhouse effect on Mars, and the Martian temperature will skyrocket over time. There's a theory that talks about this project where we drape a magnetic field around Mars that you might actually see a difference in 10 years. Okay, certainly not livable, but maybe in 10 years, we could actually see a little bit of a difference. Wouldn't that be something? Yeah. And yes, Genghis, you got it right. It's the Van Halen belt. Okay. No, the Van Allen belt, but Van Halen belt, I like it. It's fine. That's cool. That's right. So that all said, that's the whole concept with Mars. And now you see what's happening is we don't even have to touch the planet itself. And we can terraform it, like Tom Brown's saying. We can actually terraform Mars without ever even interacting with it. Now that is the best way, if you ask me, So I think it's pretty cool. Anyway, I have been going on for quite some time. I don't even know if Daryl's still awake at the other end of this. I probably put him to sleep.
Not quite.
Not quite, but almost, right? Anyway, folks, I want to thank you so much for coming out tonight. I leave you this picture of the comet tonight. And one last thing that we might be able to just see, let me make sure it's still here, is I think it's going to be here. Yeah. Okay. This is the location of Comet NEOWISE right there. Okay. The Earth, as you can see, is right here. Okay. And NEOWISE has gone around the sun, and it's heading back out to deep space. You can see that it was actually closer to us and had been at closest approach I think it was a couple days ago, right, Daryl? Was it 22nd?
23rd.
23rd, okay. But tonight we noticed that the core of the comet was actually pretty bright. So it was still a little bit bright, but it was closest to us. But it did go around the sun. It did evaporate a little bit. And it's going to head out on its path. And as I said, it looks like that's just right over there. But if we actually back out, we see that we're looking at an ellipse that's really quite a distance away. This outer ring here, that's Pluto. Okay. Remember, it took us 15 years to get to Pluto at the fastest speed we know how to go. All right. Well, there is the orbit of this comet NEOWISE. Okay. And it's called 2020 F3. That's actually comet / 2020 F3. That's actually the actual name. So 6,800 years from now, it'll be back. And it'll probably look much like it does today as it's leaving. But it's going to be, it's definitely going to be getting dimmer over time and will eventually evaporate. So I am very happy that we could see the comet all night tonight. So I want to thank you, Daryl, for coming on. That's very good of you to come.
Well, thank you. Thank you for having me on. I'm glad I came.
Me too. I am too. And I will talk to all of you the next clear night. And if it's clear tomorrow, then maybe we can do some more comet hunting as well. There's other comets in the sky too, by the way, and we've only looked at NEOWISE, NEOWISE here, but we'll look at some of the others if we can find them. I'm not sure which ones are the best ones to look at right now. I'll just have to look through all the notes and figure out which one might be the best one to see. But I want to thank you guys for coming out. And on behalf of Amanda, who's not here, I'm sure she would say, have a good night, guys. Daryl, anything you'd like to say?
Well, thanks everybody for coming. I'm tired. I'm going to go to bed.
Yeah, I don't blame you, I know. But okay, well, that's good. So tonight was Comet NEOWISE, and we are also going to be viewing the summertime sky objects also in the next stream. But until then, guys, I wish you the best, and hey, keep looking to the skies, all right? So we'll see you later, and good night, everybody.